Good day, everyone. And in this lesson, we will be talking about the properties of vectors. Okay, but first and foremost, we have to know what the modulus of a vector is, right? Now, the modulus of a vector A is equal to its magnitude. So we have to know that the modulus of a vector is equal to its magnitude. Okay. Now, the second thing that we will have to talk about is equal vectors. What are equal vectors? So having the vector A and get a straight line, okay, somehow straight, and also the vector B. Now, A, the vector A, can be said to be equal to the vector B only if A and B have the same direction and also they have the same magnitude. Okay, so they should be going in the same direction, which is represented by this arrow, and also they should have the same length. So this can be actually 5 centimeters, and they should also be 5 centimeters. This arrow can be pointing to the north, and this arrow should be also pointing to the north if they are equal vectors. And when this condition is met, we can say that these two vectors are equal, right? Now, the second thing we will be talking about is negative vectors. Now, having a vector A, right, when we negate A, we have to really take note of this. This is what we obtain as a result of the negation of A. Now, what does this two diagram mean? The length is actually the same, but the direction is actually different. So we have this vector A going in this direction, and its negation is going to the opposite direction. Okay, but they have the same magnitude, means that they have the same length. So the length of A is equal to the length of negative A if A is equal to negative B with respect to negative A being the negative vector of A. I hope that's clear. Now, they are actually equal vectors with opposite direction. Our next topic is multiplication of vectors, right? Multiplication of vectors. Now, I'll still be using the vector A, but now let's draw it in this direction. Sorry, let me change this color. The vector A. Now, when we multiply a vector by a scalar, we actually get a vector, right? So we have to take note of this. When we multiply a vector by a scalar, we actually get a vector. Now, let lambda is written in this way. This is not actually nice, but let's take this to be lambda. Let me write it again. Now, having lambda to be a positive real number, right? The vector a lambda will actually look something like this. Now, as we can see, its direction is the same, hasn't changed, but its magnitude, which is represented by its length, has actually increased, right? Now, the reason why this direction is also the same as this direction is because we put a caveat at the beginning, and that is provided lambda is a positive number, right? Now, lambda is not can also be a negative number. And when lambda is a negative number, I'm sure you know what I'm about to do. The arrow goes in the opposite form. Okay, so this is the representation of negative lambda, right? So the fact that we are multiplying it by a scalar doesn't mean that it always have to go in one direction, that is the same direction of the vector. But as we've seen in these two instances, there can actually be a change in direction of the vector. Now, we will also want to talk about addition of vectors. Now, we'll be explaining this further in our subsequent videos, but let's get the basic of addition of vectors. Now, let's have this vector. This time, I will no longer be using a, right? I think I have to change it. I have been using a too much, right? So let me try and make this straight. So, taking the vector a, b, c. Right now, this is not yet a vector. Why? Because it has no specific direction. But now it has a direction. So we can call this as a vector. So let's label the length the vector ACP. Now let's label the vector CBQ. Right. Now, as I said earlier, if this were to be normal ordinary mass, if P was 2 and Q was also 5 centimeters and we were asked to add, we will just add 2 to 5 centimeters and we would have obtained 8 centimeters. This is actually quite simple, but this doesn't work in vectors. As we explained that this value is as a result of its direction and also its magnitude. Now, we have to take note of these arrows. These arrows are actually moving in this order, and the sum of these vectors is actually in the opposite direction of these two vectors, right? So definitely the magnitude of vector AB would be greater than the magnitude of vector AC plus vector CB, right? So adding these two, we get a vector P plus Q. And take note, when P is 2 and Q is 2, we still don't get a 4 for this. These are not actually number values, they are actually vectors, right? So we have to work in the language of vectors. Thank you very much for watching this video. Please subscribe to be kept updated. This is Teach Me Maths, and thank you all.